All right. Good morning, everyone. We've got a great crowd this morning. Thanks for coming out. Welcome to the Wyoming County Cultural Center, Dietrich Theater. I'm Erica Rogler, Executive Director, and we're excited for today's free Science on Screen showing of the movie Jaws. This showing will be followed by a really cool presentation by Dr. Linda Auker. She's a marine biologist, and she's an assistant professor of biology at Misericordia. This program is an initiative of the Coolidge Corner Theater with major support from the ALFRED P. SLOAN Foundation. So let's give them a round of applause. Prior to the showing of Jaws, Dr. Auker is going to tell you a little bit about herself and tell you what to expect in her program after the film that we hope you can stay for. So now please join me in welcoming Dr. Linda Auker.
Thank you very much, Erica. It's great to be here. I'm happy to see everyone here. Yes, my name is Dr. Linda Auker, and I am your local marine biologist here in NEPA. I am an assistant professor of biology at Misericordia University, as Erica mentioned. A little bit of my background. Actually, I'm not a shark biologist, but, unlike the marine biologists in the movie. However, thinking about sharks, thinking about how different organisms interact with each other and the role that they play in ecology in the ocean is really important. So even if I don't specifically study sharks, I'm still very interested in shark conservation, right? So what I do study is I'm really interested in invasive species, and I deal a lot with invertebrate animals, all right? So my background, I got a bachelor's in marine science and biology at Long Island University, and I got a master's in oceanography at University of Rhode Island, and my PhD is in zoology at the University of New Hampshire. And I've been teaching for over 10 years at various colleges and universities, Siena College in Albany, St. Lawrence University up in northern New York, and this is finishing off my second year at Misericordia University. So happy to chat with anyone afterwards as well about what it's like to be a marine biologist and how do you become a marine biologist if anybody's interested in that as well. But what you could expect after the showing of the movie is some discussion of, well, first of all, what inspired Jaws. Should we be worried about shark attacks? How often do they happen? And what ecological role do sharks play in the ocean? So these are some of the things that I'm going to discuss with you, and I'll be also happy to take questions afterwards, all right? But with no further ado, let's start the movie, okay? So here's Jaws.
This is the best one.
So what I'm going to talk about today, and I'm going to make this brief since we did just sit through a 2-hour movie, I'm going to talk a little bit about sharks in general. As I said when we got started, oh yeah, you have another question.
How old are sharks?
How what?
Old?
How old are sharks? Like how long they've been on the earth?
Yeah, how old are they?
They are millions of years old. I'm actually going to talk about that today.
Oh.
Yeah, very cool, very good question. So as I mentioned, I'm a marine biologist, but I'm not a shark biologist. However, they do play a major role in marine ecosystems, so we're going to talk about that a little bit. So the reason we like sharks so much is, the reason there's a movie called Jaws, the reason there's other shark attack movies like, Megalodon, if you've ever heard of a Meg, that's another one, is really nicely captured by this quote by E.O. Wilson, who's a sociobiologist. He says, "We're not just afraid of predators, we're transfixed by them, prone to weave stories and fables and chatter endlessly about them. Because fascination creates preparedness, and preparedness survival, right? In a deeply tribal sense, we love our monsters, okay? That's why Jaws was so popular. You may have heard it was kind of difficult to catch in the movie, but when they're arguing with the mayor of Amity, they were talking about the New Jersey incident. They said it very quickly. And they said that there were, 5 people killed in a matter of about a week. And that's a real thing, all right? So I have a news article here. This is from 1916. This is an article from the Philadelphia Inquirer about this quote-unquote man-eating shark that traveled up the coast of New Jersey and killed 4 people and injured a 5th, all right? And these shark attacks lasted between July 1st and July 12th, so around the same time of year that's going on in Jaws, right? And there's a lot of books about this true account. So I'm just going to show you one. One's called Close to Shore. And so by Michael Capuzzo. And of course, fictional accounts were inspired by this as well, which is Jaws, the book, published in 1974, written by Peter Benchley, okay? Now, what happened during these shark attacks? Well, if you notice, there we go. Up on the left-hand side, I have a little map. When I went too far. There we go. So the first guy that got got killed by the shark. He was swimming off the coast just north of Atlantic City, New Jersey, and that's a picture of him right there. And July 6th, about 5 days later, further up the coast, a second guy named Charles Bruder got killed by a shark, all right? And this is a news article about that. And then on July 3rd, apparently I'm moving too quickly here. There are 2 individuals here, Lester Stillwell, who was 11 years old on the left, and Stanley Fisher, who was an older young man on the right, who tried to rescue Lester. Both of them got killed by this shark. And then about a half hour later, another young man named Joseph Dunn survived the shark attack, but he was missing a leg, all right? And then to go back to that Philadelphia Inquirer article, that was the shark that was caught, all right? So, if we go down here, based on since this is a true story, it seems like, well, maybe this is a really real thing we need to be afraid of, right? Go out, we might get eaten by sharks. But there's a few facts I want to share with you, a few misconceptions, right? Now, first thing we want to look at are global shark attack statistics. And thankfully, someone did this just 2 years ago in 2019. If you could click on that picture, there we go. These are the countries and regions where the shark attacks were analyzed, or shown in blue here. So the United States is one of them. We have had the most shark attacks. But I'm going to give you an important piece of information. You can also see Brazil, Mexico, Australia, New Zealand, and other places as well are included here. Okay, move on. Thank you. And the sharks that were included in these shark attacks, the ones that tend to do the most attacking, are listed here. Okay, we have the blacktip shark on the left. There he is right here, maybe. Not sure why it's not showing up. We can just show the pictures. And then we have the spitter shark, the bull shark, the tiger shark, and the white shark, right, or the great white shark. So these are the ones that are most likely to be to attack, essentially, right? These are your quote-unquote man-eaters. Now, there is a stipulation about that, right? Man-eaters. Sharks aren't really interested in eating us for dinner, right? But they're samplers. They see something that sounds like food or looks like food or smells like food, and they want to try you out and see how you taste, right? And that's why some people might survive shark attacks, but they'll have parts of their body missing, right? Usually when people die from shark attacks, it's because they've been injured so much that, that they can't survive those injuries. So we're not really all that tasty to sharks, but because of the splashing around in the water, They think we're a fish or a seal or something else they want to eat. This table here is from the same study, 2019, where essentially you'll see the United States as the most shark attacks. That's that last column, is the number of shark attacks. But that isn't per year. That's from 1960 to 2015. That's over a span of 55 years, all right? That's the first thing. So we've had 1,215 shark attacks between 1960 and 2015. Now, if you look on the first column, you'll notice what percentage of those were fatal during that time. 2% in the United States were fatal between 1960 to 2015. And you can go down the list and you'll see that, so there are some areas like Ecuador, for example, had 11 shark attacks, no fatalities. But there's other areas like, Mexico, which had 33 shark attacks during that 55-year period. That's less than one attack per year, but they were 48% fatal. All right, and there's a lot of different factors that might determine fatality rates. Okay. So here's a quote right from that paper. They found, based on their studies, that about 85% of shark attacks globally are not fatal. Now, that's not to say it doesn't, it's not horrible to be attacked by a shark, because it most certainly is, right? They were paging through a book in the movie showing all these different horrible shark injuries. It's not fun, but 85% of them are not fatal. And this graph is just showing trends over time of fatalities. In some locations it's going up, other locations it's going down. A lot of that may be due to more reports, more crowding of beaches, right? More areas that have a lot more people may also result in more shark attacks. So, Ferretti et al. In 2015 also studied shark attacks, and one thing that they said was in the ocean, although many shark species are facing worldwide declines, recorded instances of unprovoked attacks by sharks on humans have been increasing, stirring public concern and generating radical policies such as calling. Calling is hunting sharks for the sake of hunting them, trying to kill as many as you can, right? Going after jaws, right? So, why do we need to protect sharks, right? They are they're doing shark things, right? They're attacking people. Why do we need to protect them though? Right? So, this is a rather long quote, but this gives you some important statistics about how many sharks we have on the planet and how many have been killed, right? So the global catch and mortality of sharks from reported and unreported landings, discards, and shark finning, all right? So we're talking about sharks that are being caught for food or other purposes, including shark fin, as well as those that are caught as bycatch. Right? So what bycatch is people might go out and want to get a completely different type of fish, right? Or different species of seafood, and in their lines, their nets, they catch sharks unintentionally. But a large percentage of organisms like dolphins, sharks, etc., that are caught unintentionally do not survive, right? So they have a high mortality rate as well. So, estimated at 1.44 million metric tons for the year 2000, only slightly less in 2010 at 1.41 million tons. So based on analysis of average shark weight, this translates into a total annual mortality estimate of about 100 million sharks in 2000 alone, and about 97 million sharks in 2010, with a range between 63 to 273 million sharks. That's a lot of sharks that are being killed. Right? And there's lots of reasons that sharks are killed besides fishing. And these include habitat loss, right? Any devastation to habitats like coral reefs, for example. There are shark species that they live pretty much only on coral reefs. And if coral reefs are damaged, those sharks no longer have a home. Calling and persecution, oh no, there's a shark attack, so we have to go out and kill all the sharks in this area, right? Well, climate change is another one as well. All right. So there's 3 areas that are shown on this map. These are the areas where sharks are the highest threat, or they are threatened most highly, I should say. Right. This is where we've seen the greatest decline over the past several years. So the Mediterranean, the Red Sea, and kind of the Indo-Pacific region north of Australia. Okay, we can move on here. There we go. And so this shows in this map as well. Again, this is the very same thing. The darker the color, the fewer, the more sharks that have declined in that particular area. All right. So what I'm going to do is I'm going to play a quick video for you from the Pew Charitable Trust that talks about protecting sharks across the globe. There's a lot of different cultures that not necessarily rely on sharks for food, but rely on them for aesthetic purposes, spiritual purposes, etc. And they're very interested in protecting sharks. So we're going to go ahead and play that now. So you can see that, there's this ecotourism industry as well that a lot of countries depend on for income, right? And that includes things like diving, checking out the sharks in the area, looking at the coral reefs. Anything that happens to these environments can have huge economic impacts as well. All right, so I'm going to give you guys 3 shark myths and facts, all right? First one is all sharks are voracious, predatory machines, all right, like Jaws. So we could scroll down to the next picture because I'm afraid that my, yeah, there we go. All right, so if we take the little slider and slide it to the right, yeah, like that. What we're seeing here is what we probably think of, right? When we think of a white shark, great white shark, when we think of sharks, right? Because that's the most famous depiction of sharks. But if we slide that slider over to the left, what we're going to see here is the largest fish in the sea is a shark, known as the whale shark, right? Whale sharks and basking sharks, which are 2 of the biggest shark species, are not predatory in the way that we think of as predatory, all right? They're filter feeders. So what they do is they open their mouth really, really big and they capture as much plankton and krill as they can, and they close their mouth and squeeze out the water, and what's left is plankton and krill. They're not going after, fish or anything else. They're getting all the tiniest things in the ocean, right? Much like a humpback whale or other types of these, really large whales like blue whales. So these big animals are not big predators. So the fact here is some sharks are filter feeders, like whale sharks and basking sharks. They eat plankton and krill. So I'm going to show you just a little clip from this video. This is from the Georgia Aquarium on whale shark feeding time. And all they're doing is they're putting a little scoop of food into the water, and you can watch the shark kind of follow the person around and eat the food. Yeah, we can drag it around, and this is a 3D video. If you Google this yourself, look at it on YouTube, you can kind of play around with it as well. But this is one of those 3D experiences, which means you can drag the video and kind of see all different parts of the pond, the pool that they're feeding in. So if we go back up, if we can, there we go. And then you can pan around the video so you can capture the shark there. There he is. They are enormous, so it's kind of swimming right in front of the camera. They're completely gentle beasts, right? He's not interested in the fish surrounding him. He's only interested in the food that the feeder is putting out, which is very small little pellets. There's some rays as well, which are close relatives of sharks, right? Sharks and rays are known collectively as elasmobranchs. Okay, so we can go ahead and go on to the next thing here. There we go. All right. So myth number 2, Quint needed a bigger boat, right? Remember when Brody walked backwards into the cabin and said, we're going to need a bigger boat, right? A little fun fact is that line was completely improvised and on the spot and became one of the most famous lines in the movie, right? So here is Brody looking at Jaws when he first sees him for the first time. And the reason, of course, he has that look on his face is because we saw Bruce, but we saw Jaws. So let's go ahead and take a look at this. This is installing Bruce in the Academy Museum in November 2020. Okay, to kind of get an idea of the size of this guy, and if we could scroll down here, the fact is, well, it depends, right? We know the orca boat that they were all on wasn't a very big boat to begin with, so yeah, he probably did need a bigger boat for a great white shark. But how big are sharks anyway, right? So I mentioned that whale sharks, and if we can scroll down just a little bit, because I don't want to pass it up a little bit. Yeah, there's the top two are whale and basking sharks. Those are the largest sharks. So we have 33 feet for the basking shark, 46 feet for the whale shark, right? The one below that is the great white. So that's your largest quote unquote man-eater at about 23 feet. So yeah, it's close. It's close to what they were saying for Bruce. But in the movie itself, all of the techniques they used, the model they used as Bruce the mechanical shark made him look way bigger than that, all right? And then we can look at some of the other sharks as well. Megamouth is 15 feet, nurse sharks are 13 feet, makos are 8, and we get smaller and smaller. So if we can scroll down there to the bottom, we see that there's even a shark that is 6 inches, the dwarf lantern shark. And this also doesn't include the the dogfish, right? Dogfish are, relatives of sharks. And he talked about squalids when he was looking at the woman's remains, and he talked about, oh, this is probably a squalid. Well, a squalid now used to be including all sharks, now just includes the dogfish, which are relatively harmless to us, at least. All right. Oh, that big giant jaw on the left-hand side, anybody know what that is?
Megalodon.
Yes, that's the Megalodon, which is a prehistoric shark I'm going to talk about real quick in a minute. So if we click on this picture of this article here, just to kind of give you an idea of the average size of, say, great white, this is an article where these are a bunch of marine biologists who captured Nikumi, who is believed to be the largest great white shark found in the Northwest Atlantic. So the Northwest Atlantic is where the setting of Jaws is. And just kind of look at how big they are compared to the shark versus how big the shark looked compared to the movie, right? To me, this is always surprising because it looks really big in the movie, but it's still a big animal, right? But they're a little bit smaller than I think we imagine. So we X out of that, and I'm gonna scroll down here, actually click on that picture of Bruce, and this is Bruce himself, and this is the production designer with his arm up into his face to fix something, and it kind of gives you an idea of the size they were going for in the movie, right? They're trying to make him as big and scary as possible, right? So, myth number 3, sharks are mindless man-eaters that survive millions of years of evolution without change. So the Jaws trailer at the very beginning, it says, there is a creature alive today who has survived millions of years of evolution without change. A mindless eating machine. It will attack and devour anything, right? And we saw, Hooper pulled out a license plate, a metal can from the tiger shark. By the way, that tiger shark that they showed that they had caught, thought was Jaws, was a real shark. And it was a shark that was killed in Florida and brought up the coast. They had to put it on lots of ice for the movie, but it started to rot. So by the time they had it strung up in the movie, it was not smelling too good. So people didn't really want, all the actors and extras did not want to be standing next to it in those scenes, right? Just wanted to point that out. So what's interesting about this is sharks are really incredible animals, all right? Sharks are incredible animals. And this is an example, this is another elasmobranch called a chimera. It's a very close relative of sharks. And what you can see here, it's got these little lines all over its body. Maybe if we click on it, we can see it a little bit better. You see all the little lines it has all over its body? Those are the lateral lines. And in the movie, Brody is looking through a textbook about sharks, and you see the lateral line pointed out, and basically it's there to be able to sense vibrations and fish in distress, right? These are predatory animals. So they also have these little things on the front of its face called the ampullae of Lorenzini. It's another sensing structure. Sharks have them as well. Okay, so we can go ahead and so they can detect vibrations in the water as well as electrical fields. I'm not going to play the next video, but if we just go down and I'll point out something about it, because it is rather long, but you're welcome to go onto YouTube and check it out. This is from the Smithsonian, and it's called A Shark's Entire Body is an Ear, right? And it really is. They go through and actually dissect a shark in this video, and they show the lateral line, and they describe how it works in great detail. So it's a really cool video. I encourage you, if you're interested in this, definitely check it out, all right? So if you go to YouTube, look up A Shark's Entire Body is an Ear, you're gonna find the same video. So we're gonna go down to the next fact, part 2. Sharks changed quite a bit over the last several million years, all right? So what we have here is this is the earliest known shark. About 450 million years ago, existed during what's called the Silurian period, first ancestor of sharks. And this is where we see the one characteristic that all sharks and rays have is the fact that their skeleton is not made of bone, it's made of cartilage, all right? This cartilage is what makes up your nose, right? You have it in some of your joints, etc. Well, this guy is made completely of cartilage. So this is where we first see that about 450 million years ago, all right? So we click next here. So kind of the next evolutionary step that sharks took was shown here in Xenacanthus about 400 million years ago during the Devonian, the early Devonian. And the Devonian is often known as the age of fishes for good reason. There's a lot of diversity of fishes during this time. This is the first fully developed shark, lived in fresh water, and it was very eel-like, all right, very eel-like. And they're kind of cute, but of course this is somebody's artistic rendition of it. Okay, go on to the next one. And this is just showing a fossil. This is Cladosolach, I think is how you pronounce that. 375 million years ago during the late Devonian era. This is where we start getting bigger and more shark-like. All right, so we start to see these wider fins and larger size, about 6 feet as I mentioned. And this animal has a rounder nose though than our modern sharks do, and their jaws are inflexible. All right, so shark jaws are way more flexible, but that was an evolutionary step that came later. All right, so we go to the next one. All right, so Stethecanthus, starting in the Carboniferous era, we start to get some really weird body types, right, showing up in the fossil record. One of them is Stethecanthus, which looks like he has an anvil on his head. I believe it's a modified fin. There's another one in the fossil record that looks like a unicorn. It's got a horn on its head. There's a massive diversification. We end up with about 43 different shark families around this time. Next. All right, we're slowly moving through time here, but we're starting to see these animals show up, becoming more and more shark-like. So this one is Hybotus, 200 million years ago during the Jurassic era, which, you know, all of our favorite dinosaurs are around that time. This is where we start to see 12 new families of sharks appear. And this is where we start seeing the flexible jaws. The mouths are starting to move under the snouts, right? So think of everything you imagine a shark to look like. This is where we start to see that body type. And then, of course, the tail fins are modified for even faster swimming. So they're becoming quite the predator here. Go on to the next one. And this is the Laminoid Sharks. So the Laminoids are the groups that include all of the sharks that we know of today, we know and love, that are quote unquote the man-eaters, the great whites, etc. And this is also the same time, this is during the Cretaceous era. This is the same time we see filter-feeding sharks appear, as well as deep-sea sharks, like the goblin shark. Their predecessors show up at this time as well. Okay, next. And then 60 million years ago, we see Megalodon, right? Megalodon was 65 feet in length. He made jaws look super tiny, right? He was 30 tons, had 7-inch long teeth. And this is the mouth of a megalodon. I'm not sure where this picture was taken, but I tried to include some people in the background for scale, just so you can kind of see this is a huge, huge, huge animal, right? Next, I believe there's one more. Yep. And so about 20 million years ago, we haven't seen much of this guy, have we, right? 20 million years ago, this is kind of the last major diversification of sharks, where we start seeing our friends, the hammerheads, begin to show up, okay? So, we can go ahead and scroll down. Oh, I guess I can scroll down. There we go. Yep, perfect. So, sharks are what you might call terrors of the deep, especially to other animals, right? Seals, penguins, small whales, things like that, right? Other smaller sharks, rays, fish, etc., are all prey for these quote-unquote man-eating predatory sharks. So what purpose do they serve, right? It's not the greatest question, but it kind of gives you an idea of what role they play. Maybe that's a better way to ask that question. What role do they play in the ocean? Well, I mentioned I'm a marine biologist. My focus is on ecology, how organisms interact, right? So one thing that I can show you here, this is one particular species of shark. Thank you very much. This is the blacktip sharks that have declined in the United States, off the coast of the United States, in North Carolina. And as they've declined, in the top graph, you can see the line going down. That's the population of blacktip sharks. But what's interesting is at the same time, cow-nose rays, their population is going up, all right? And then at the bottom, we see these scallops, their population is also going down. So what's happening is something we ecologists call a trophic cascade, right? When you eliminate your apex predators, whether it's a shark or a wolf, right? Or think of any other major predator, a lion, what will happen is the food that it eats, right? The animals it eats are going to increase in population because their predators are gone. And as a result of that increase in population, whatever that animal eats that just increased, their food is going to go down. So what happens here is when the blacktip shark is removed, cow-nose rays go up, but scallops go down. And that's a problem because scallops are filter feeders. They eat all this plankton. And if you don't eat up all the plankton in the water, what happens is it causes a plankton bloom. Some of these plankton are toxic. Others, if you have an excess of plankton and they die, the decomposition of that plankton causes something called a dead zone in the deep. It uses up all the oxygen. So there's major repercussions from losing our apex predators. Okay, I think we can X out of that. So this is not the best graph for here, but basically what I'm showing you across the top are great sharks, right? These are all showing up. These sharks are in decline, right? These are your blacktip, your white sharks, etc. In the middle are what we call our mesopredators. Meso means middle, so these are the animals that are eaten by the sharks. They're all increasing. And as a result of their increase, we're seeing the bottom of the food chain animals, the scallops, decreasing. And as a result, plankton are increasing and causing all kinds of ecological and environmental issues. Okay, we can fix out of that. All right, so you might be asking, well, what can I do? All right, I hope you're asking, what can I do, right? Because what happens if we remove sharks from the environment, if we have a major if we see sharks decreasing in the environment, there's a lot of problems that will happen, right? We're going to see major changes in ecosystems, the health of ecosystems, also economical changes, cultural changes, things like that we saw in that Pew Charitable Trust video from earlier. So there's a couple of things here that I want to mention. Is first, to educate yourself about sharks. Y'all are here to learn about sharks, which is awesome. And spreading the news, just, when people say, a myth about a shark, to say, actually, that's not the case, right? Ask your leaders in Congress to ensure that shark finning in the U.S. waters is not happening, all right? Anything we can do to stop that. Any climate change initiatives are supported because climate change, and if you guys are aware of this, as the temperatures get warmer, more carbon dioxide in the atmosphere. What happens when you mix carbon dioxide with water? It creates something called carbonic acid. And so when the oceans are getting more acidic over time, the more carbon dioxide is getting sequestered into the ocean. We often think of the ocean as this great storehouse of carbon dioxide. It's actually impacting the chemistry of the ocean. We're seeing declines in corals. We're seeing declines in things like scallops and mussels and other things that need to calcify because they're unable to make a calcified shell due to increasing acidity in the ocean, which of course will impact the food chain and impact the sharks. Don't eat sharks, right? They're not actually that healthy for us. There's sometimes in some places on the market, I'm not sure how local you can get it, but there are shark cartilage pills you can get that are supposed to help with all kinds of things. There's no medical reports that say those are all helpful. And some claim that they are from, common species of sharks. There have been studies shown that the species of sharks that were harvested for those cartilage pills were misrepresented, and using DNA, they figured out some of this cartilage actually came from threatened species of sharks. Don't pollute, right? Engage in ways to clean up our waterway. It's probably the best one we can do even locally, right? Our waterways go into the Susquehanna. The Susquehanna empties into the Chesapeake. The Chesapeake empties into the Atlantic. So any pollution that goes into our waterways here will eventually end up in the ocean. And if you are able, shark research and conservation initiatives are always seeking donations. The more shark research we have, the better. The Shark Research Institute is just one of those places. But probably the best thing that anyone can do is just educate yourself to learn more about these creatures. Of course, there's Shark Week every year on the Discovery Channel, and sometimes there's some really cool stuff on there as well. So, one last thing I want to mention. Whoops. All right. Last words. I was not born when Jaws came out. I don't know if that dates me or what, but what's kind of funny is when I was growing up, this cartoon, I'm going to play the intro for you, some of you may recognize it, was on TV all the time. This is what I grew up with. And this came out a year after, this particular cartoon came out a year after Jaws did, and nobody paid attention to the very last thing the cartoon character says in the intro. I don't get no respect, right? This is a year after Jaws. Everybody's afraid to go in the water, afraid of sharks, and out comes this cartoon. There's a couple others that came around at the same time. I think one called Mr. Jaws. I think it was also Hanna-Barbera. How many of you have seen that cartoon before at one point? Okay, good. So I just want to thank everybody for attending and listening to me talk about sharks for a little bit. I'm happy to answer any questions you might have to the best of my ability. And I'll be more than happy to answer questions about marine biology in general as well if you have those too. All right, any more questions? Okay, if not, then thank you so much for attending. I really appreciate it.